Welcome to another entry into our FJA math notebooks. For today's entry, you will be titling this volume. You'll need this sheet of paper that came out in your notebook packet pickup, and then this sheet of paper as well. That's really it. And then on top of that, always a pencil, scissors, glue. We're going to start by cutting out these sheets. You're going to need this, and you're only going to need half of those, cutting out on the dotted lines. All right, we're going to start with the circular piece here. Fold along the solid lines. Before we go ahead and glue this down, we need to make one note at the top of our paper here. This note in here, remember, volume is a cubic measurement, and the unit will always be raised to the third power. Example, centimeters cubed, inches cubed, and feet cubed. So remember, when it's cubic, it's because we're talking about three-dimensional objects. We're no longer talking about just a circle flat on the page. We're talking about a three-dimensional object, like this cube that I have here. So this cube, as you can see, it's three-dimensional, right? So this is one cubic unit. So if I were to make a larger cube, a cubic prism, make it this big here and see if I can hold it up for you all. Here's our larger cube. You can see that this is made up of 8 cubes. And the way that we do that, and this will be review from the week, remember that if we looked at this as two-dimensional, this is a 2 by 2 square. So the area is 1, 2, 3, 4. But once it's three-dimensional, we add the dimension of length. So base times height times the length. And now we can see how long it is. And this is actually made up of 2 rows of cubes, 1 and 2 there. And so what we have is a 4 area base, but it's 2 deep, or the length is 2 deep. So that means you take that 4 and you multiply it by 2. So this is an 8 cubic unit cube. Today we're going to be talking about the three-dimensional object of a cylinder, which is just like my glue stick here. This is a cylinder. So in this case, the base of it, we look at what's the area of this circle, and then we multiply that circle by how many circles would be stacked up in that cylinder. So let's talk about what those formulas are. So we're going to be talking about a cylinder. It's right here, like the glue stick, a cone, like this one, and then a sphere, which is like a perfect ball. A basketball is a sphere. So what we're going to do is we're going to glue this down, keeping these little flaps here available. So you're going to glue down on the triangle in the middle. So here we have it. Let's start with the cylinder. So the cylinder is V volume equals pi times the radius squared times height. What you'll notice is a cylinder is this, and then each end is really a circle, right? It's just like this. So the first part of this equation here, volume equals pi r squared, that is just the equation to find the area of a circle. All that is pi r squared. That is exactly what we wrote down a couple of weeks ago on how to find the area of a circle. The only difference is a cylinder is one circle stacked up until you get to this other circle. So we multiply it by the height, the measurement of the height. That's going to give us this measurement right here. That tells us how many circles we're basically stacking on top of each other in order to get that full three-dimensional object. So let's take a look at this one. We're going to call this, we're going to look at this example here. Radius equals 5, height equals 15. We're going to call these centimeters, okay? We're going to use this formula. So flip this up here, and on the back here, we're going to rewrite our formula. So the volume of a cylinder is formed by doing pi times r squared times the height. So first we find the area of the circle that makes up the base, and then we multiply it by the height. In this case, the radius is 5 centimeters, the height is 15 centimeters. So let's plug that in. Radius is 5, so we're going to do 5 squared times the height, which is 15. We'll put the units in at the end. Well, remember PEMDAS, parentheses. Well, technically we don't have parentheses. I just put those numbers in parentheses to be clear, but we can erase them if you want to. Really, this is just pi times 5 squared times 15. So maybe it looks a little bit better like that. Now, PEMDAS, parentheses, then exponents. Oh, we have an exponent. So before we can do our multiplying pi times this and then multiplying by 15, we've got to simplify our exponent. So 5 squared, what does that mean? That's 5 times itself twice. 5 squared is 5 times 5. So we rewrite that as volume equals pi times 25 times 15. All right. Well, now we can do what's 25 times 15. Feel free to bust out a calculator for this, or you can do it on your own. I'm going to go ahead over here, bring out my calculator. 15 times 25 is 375. Volume equals pi times 375. And now we just multiply 375. I'm going to put times 3.14 for pi, and that's 1,177.5. So volume equals 1,177.5. And last, our unit, centimeters. So we're going to put it in centimeters cubed. And that is our answer. Let's talk really quickly about cones. Cones are kind of interesting. Cones, on the base, you've got a circle. You've got a circle for your base. And then it tapers up to a cone, and it would taper on all 3 sides. I don't have a good example for you, but you can maybe imagine like a classic party hat where it's a cone. So the base is a circle, and it slowly decreases going up. And the formula for a cone is volume equals 1/3 times the base. When they put the big B there, what they're saying is big B is actually, we want to know the area of this circle at the bottom times H. So the way I'm actually going to rewrite that for us here is that it's actually going to be volume equals 1/3 times pi times r squared, because that's how we find the area of that circle, times height. So really it's the same formula as cylinder, except we just multiply it by 1/3. It's pi r squared times the height times 1/3. So let's do the sample problem. A radius of 4 inches and a height of 13 inches. So I'm going to write it again. So there's our formula, 1/3 times pi times r squared times height. Basically cylinder, but we're going to multiply it by 1/3. So let's plug this in. Volume equals 1/3 times pi times the radius is 4 squared times the height, which was 13. So now we simplify. Remember, we have to do our exponents first because of PEMDAS, our order of operations. So let's simplify that. 4 squared, 4 times 4, that's 16. So 1/3 times pi times 16 times 13. Well, I'm going to again get out my calculator here. So let's do that. Start over here. 16 times 13. 208. So volume equals 1/3 times pi times 208. 208. Well, let's do 208 times pi, 3.14. That gets us 453.12. Volume equals 1/3 times 653.12. And then we just multiply that by 1/3, which, remember, when we multiply by 1/3, it's the same as dividing by 3. Multiplying by 1/2 is the same as dividing by 2. So if we're multiplying by 1/3, I'm just going to click divide by 3. 217.7. So the volume here equals 217.7 inches cubed, because this is a 3-dimensional object. And lastly, let's talk about a sphere. So this is a sphere. The volume of a sphere is a little bit different. For the sphere, we take 4/3 times pi times the radius cubed. So we're going to work with centimeters again. This is 7 centimeters. Let's go ahead and write this down. The volume equals 4/3 times pi times our radius to the 3rd power, radius cubed. So the radius is 7 centimeters. Plug that in. Volume equals 4/3 times pi times 7 cubed. Now, you will be forgiven for not knowing what 7 times 7 times 7 is, 7 cubed. So what we could do is 7 times 7, that should be easy, that's 49, times another 7, that is 343. Volume equals 4/3 times pi times 343. So I'm going to take 343 times pi now. So times 3.14, that is 1077.02. So volume equals 4/3 times 1077.02. And now, when we're multiplying by 4/3, remember, this is technically multiplying a fraction. So I could technically put that over 1. So all I'm going to do is I can multiply 1077.02 times 4 and then divide it by 3. So times 4 equals that, divided by 3. So the volume of this sphere, is 1,436 I'm just going to round it to 0. So the volume equals 1,436 centimeters cubed. On the back of this page, we're going to glue down the spine here of this little book thing, and we're going to do some sample problems. We will do one of these together, and then I'm going to let you all free to finish the bottom 2. So let's do this top one here. Meg has been saving the cans from her favorite chips to reuse to give away home-baked goodies. Okay, so it's like Pringles, I guess, because that's the only chip can I can think of that's a cylinder. After making a recent batch of trail mix, she wonders how much the container that has a radius of 10 centimeters and a height of 25 centimeters will hold. So what that's saying there is that the radius of this circle, if we were to put a dot there, the radius here of this circle is 10 centimeters, right? And then the height of the can is 25 centimeters. So from here to the bottom of that can is 25 centimeters. Well, remember, to find the volume of a cylinder, the formula we're going to use is volume equals, first we do pi times r squared, because that's going to give us the area of the circle that makes up the top or the bottom of the cylinder. And then we're just going to multiply it by the height, because remember, we're stacking those circles, the area of that circle, 25 deep to make that cylinder, times h. All right, so we do v equals pi times the radius was 10 squared times the height, which is 25. All right, well, first we've got to do our exponents. So I'm going to rewrite pi again. Times, well, 10 squared is 10 times 10. That's 100. Times 25. All right. Well, now we can combine 100 times 25. Well, 10 times 25 would be 250. So 100 times 25 would be like moving the decimal back 2 places or adding 2 zeros. So we would get pi times 2,500. And then let's do that on our calculator. 2,500 times pi, which is 3.14. So 7,850. The volume here is 7,850, what did she say? Centimeters, and then the unit is always cubic, centimeters cubed. Thanks for tuning in. Hope this was helpful.